Okay, let's pick up where we left off with some more terms about graph theory using that same graph from before up there in the corner. The next thing that we need to talk about is that each vertex has a degree. Degree is also known as valence, and the degree of the vertex is based on the number of edges that are at each vertex. The number of edges that lead into the vertex. For example, the degree of vertex A is 2 because there are 2 edges at vertex A. The degree of vertex F would be 0 because there are no edges at vertex F. There are even and odd vertices as well, and even and odd vertices just based on the degree. Even vertices have an even degree, so the degrees would be either 2, 4, 6, 8. An odd vertex is going to have an odd degree, 1, 3, 5, so forth. If you look back at that graph there, if we talk about each of the vertices, the degree of each of the vertices, the degree of vertex A is 2. There are 2 edges at vertex A. The degree of vertex B is 5. There is 1 edge from A. There is 1 edge from E. There's 1 edge from C, and then the loop counts twice because it's coming out of B and then going back to B. So there are 5 edges coming out of vertex B. Vertex C has 3 edges, so the degree is 3, which makes that an odd vertice. The vertex D, the degree is 4. There are 4 edges coming out of vertex D, making that an even degree, an even vertice. E also has a degree of 2, making that an even vertice. And then F has a degree of 0 because it has no edges connected to it. It is an isolated vertice. Okay, the next thing we also need to talk about is paths and circuits. Starting with paths. Path is a trip along the edges. The number of edges traveled is the length. And there are many paths that could take place in this particular graph. A path meaning a path from vertex A to vertex C. There are multiple ways to travel from vertex A to vertex C, and however many edges you use is the length of that path. So I could go from A to B to C, and that would be a length of 2. I could go from A to B, do the loop, and then go to C, and that would be a length of 3 because the loop counts as an edge. I could go from A to D to C and have a length of 3. So those are paths. A path has a different start and end point. You could have a path from B to E. You could have a path of a length of 1 just by going straight from B to E. You could have a path with a length of 2 by taking the loop to back to B and then to E. You could go B to C to D to E, and that would be a path of 3 or a length of 3 and so forth. There are multiple options here. The second definition that you need is a circuit. A circuit is a path, but it has the same start and end point. It's going to start and end at the same vertex. So a circuit would be a circuit from A back to A. So I could go A to D to C, B, back to A. That would be a length of 4. I could do A to B to C to D, back to A. That would also be a length of 4. You cannot repeat the edge that if you've already used that edge, you cannot repeat it, but you need to start and end at the same point. And just like paths, there have been lots of circuits that could also take place in this graph. Okay, and then the last definition that you need is a bridge. A bridge is an edge in a connected graph that if you were to take it away or erase it, the graph would then become disconnected. And I have an example here. If this is my graph, it is currently a connected graph. Remember, the definition for a connected graph is that you can get to any of the vertices traveling through the edges. So this is a connected graph. However, if I take away that edge in the middle, it now becomes a disconnected graph. So that edge right there in the middle is a bridge. Okay. I could also take away the side edge, and now it's also a disconnected graph. So that is also a bridge. So a bridge is if you can take away that edge and it becomes a disconnected graph, then that particular edge is a bridge.